Hey everybody, welcome back. Today we are going to be going over VPC networking. We're going to talk about the various subnets that are available to us. We'll probably dip into firewalls as well. This is going to be a little bit of a longer video, so it's going to be split up into multiple videos I would expect, but it's all really the same content. So I'm going to talk about it like it's all one thing, but in reality I'm going to chop it up for all of you. So first things first, when we have to network things together, right, we have to understand how we're going to address them. Right? If you hopefully remember from your other classes, every device, every entity needs a unique IP address in order to be accessible. And what that's basically doing is that it's allowing traffic on the network to understand how to send data to and from particular devices, making sure it's getting routed in the correct directions to the correct places. This isn't intended to be an overview of the basics of networking, though. It's more how the cloud is a little bit different from what you should hopefully already know by this point. So without further ado, I've got some slides here from Google on this very topic. I'm going to be skipping over some of the more boilerplatey, I suppose, advertising-y types of slides that come with it. But let's first talk about a little bit of networking. So with our traditional systems, typically we're behind routers or switches or something like that, and we are telling our various devices how to send data from device to device, right? We, again, should hopefully know this by this point. When we move to the cloud, things become a little bit, not trickier, but there's a little bit more complexity to it. So in a cloud-based environment, if you think of it pragmatically, basically, you have your local device, right? Your local PC. Let's say there's a node off here, which is your computer, right? You're behind a router. So locally, your IP address is 192.168.1. Something, depending on the brand of your router, how you have it configured. Your router is going to translate that IP address when it leaves, when traffic leaves your computer, goes to the router, goes out to the greater internet and tries to link up with the cloud. That IP address is going to be translated to something basically unique for across all devices. And I'm glossing over a whole lot of networking theory behind this. But once our traffic gets up to the cloud, we basically need to figure out how to route that packet or that set of packets to wherever it needs to go behind the cloud. And what's going to happen here is that either it's going to be routed through any of the various publicly accessible services, right? Like we have our App Engine URLs, we have our Cloud Function URLs, everything that is publicly accessible, we can access via a domain name, which would, you know, basically render out to be an IP address behind the scenes. Google is going to be in charge of all of that kind of stuff. But when we get into the more infrastructure as a service type of domain, right, we're talking virtual machines and things of that nature, we actually have to deal with the networking aspects of it. So as our traffic is going up to the cloud, we need to understand how we can basically take those packets of data and direct them to the correct locations. Now, this particular talk isn't really going to focus on the external side as much. We're going to mainly be talking about how we build up our networks inside of the cloud. So here, this nice little graphic is basically our cloud. Let's consider this our Google entity, right? The external thing that we see as the public. But behind it, we have routes to the various services. Right? We can talk to cloud storage. We can talk to cloud functions or a compute engine or whatever we need to do behind the scenes. What's basically going to be the easiest way to think about this is to relate it to a big switch or a big router blocking everything else. Everything inside of this network, we're going to treat like any other internal private network, basically. So you have your internet traffic coming from out here. It hits our point of entry, which if you need to liken it to like a switch again, or a router, that's probably the best way to think about it. Obviously, it's way more complicated than that, but that's kind of the easy way to think about it. We're going to translate any requests coming in, right? Anything coming in from the outside to our internal network. Does this go to a compute engine instance? Does this go to a cloud function that we're calling programmatically? Right, so we basically need this transition layer. Now, I'm going to skip over again some of these slides here because what I really want to focus on is the notion of a virtual private cloud network. So VPC is going to be the thing you search for in the search bar in Google Cloud. Basically, it's just an internal private network to your project, okay? And the way to think about this is that every project that you create is basically going to be this construct that is specific to you, or if you've gone through any of the security lectures already, um, basically allowable to any roles that you've given access, right? Like if I give a colleague access to my project, they can now, say, work with my virtual private cloud as well, and we can interact with each other. But this notion of a VPC, basically it's just a simulated network. So it's a software-defined network. It is a construct that is just in a software-defined entity. Again, we are doing the infrastructure as a service thing. It makes sense that our internal networks are services as well. Again, this is tied to your particular project. So if I were to create, multiple projects, I could have multiple virtual private clouds attached to those. So projects in Frederick CIS680 are going to differ from projects in Frederick 680-BigQuery demo, right? They're completely separated entities. And where this is important is that we are going to see that the IP addresses internal that get defined are going to look the same. They're going to start with like 10 dot numbers, right? We don't necessarily need to worry about clashing, which is an issue with IPs because they have to be unique, because they're probably going to be particular to that cloud, or that virtual private cloud. And depending on how the infrastructure is laid out, there may be like a wide pool of addresses assigned to, say, multiple VPCs. It just kind of depends on how we have things set up. But really, this is just, again, a software-defined construct. Now, to give you a little bit of a visual here of how this works, this gray area is our VPC network. Right, so I've spun up a new project. It probably enabled compute engine. So now I have the ability to create the VPC network is already created by default for us, luckily. But we have access to these resources. Now, what do we get out of this particular figure here? Outside of this network, you see the greater internet, or you see an on-prem computer. An on-prem meaning that perhaps we have a device that we want to link up to our virtual private cloud by, say, a VPN connection. So let's say this is our work organization. We want to VPN into this network so that it seems as if our computer is actually on site. That's kind of why we normally would have a VPN in traditional settings, but we can do that here as well, basically. Regardless, it's going to be translated to an internal request. Whether you're going through a gateway or a VPN gateway, it's still getting routed appropriately here. So we go into this VPN network, or this VPC network, and we then get routed to the particular location we need to. Now, these are going to be region and zone based. So all those regions and zones that you have been defining for your various services, this is where it comes into play. So US West 1, US West 1A, region, zone. We then see IP addresses reserved in that particular location. Now, I'm not going to go deep into subnetting, into DHCP address assignments. This is, again, networking 101. It's not cloud technology, anything specific here. But the key takeaway, though, is that based on our zone, we can set up different subnets and we can customize them. So maybe, you want to assign basically like a 16-bit reserved address where you can have 2 to the 16 power different devices accessing it. Or you want a more simpler one where you have less devices that are going to be accessing something. That's your typical 192.168.1, and then you just have a single octet of unique IPs that you can use. Can be configurable by you, I should say that. By default, what you're going to see in a VPC network is that it's probably going to be 10 dot addresses that get spun up. So while I'm kind of thinking about that, because I did not have my demo up and running here for Compute Engine, let me create a couple of instances in the background. So I just have instance one. Let's say this is central. Perfect. So we'll just do US central, make it a micro instance. I don't care about any of this other stuff because I'm not using this machine for anything. Let's create one here. And then let's also create one in, oh, let's say Europe Central 2, just for funsies here. Again, I don't care about any of this stuff. Just for fun, let's pick Ubuntu 16. Sure, that's fine. Again, I'm not using these for anything. Let's create these and let's let them run in the background while we continue talking. So we have effectively different regions and different zones that have been created for these servers, right? We can set the subnets, we can set the region, we have full access to this. Now, everything you're seeing here should not look any different than what you're used to from traditional networking. If you were in a company setting up a internal network, right? So you're a system administrator or a network administrator, you are setting up subnets based on building or based on department, and you are setting how many machines can be tied to which subnet, right? Are we going to allow a large amount of devices on the subnet or a small amount? Are you going to figure out what the IP address range is based on location by, maybe a wide area network? Are you allowing VPN connections in and you have to reserve addresses for those devices? Again, all of that's outside of this class, but you can do the exact same thing in here, which is quite nice. We can also, with our subnetting, we can extend them across zones, but it has to be in the same region. So that's one of the little gotchas here. So if I want to say extend basically a subnet from region to region, I can do that. Or sorry, from let me make this a little bit bigger. US Central 1, here is our subnet, 10.28.0.0/20. Okay, again, these are defining our octet ranges, the slash notation there. You can see that these are all configured for you by default, and you see they're all starting with 10 dots, right? You can tweak this to be whatever you'd like. I could create a new VPC network if I would prefer. And if you are doing a custom deployment, you're doing some kind of a group project where you need networking access between each other, creating a separate network for your devices might not be a bad idea. So with that, if I pop over to Compute Engine then, that's where I was before, we see our two different virtual machines. So US Central 1A, Europe Central 2A. I see this one's on 10.128, this one's on 10.186. If I go back to Europe Central, 10.186. So it's right there. US Central 1, 10.128. Exact same thing that we see here. Now, one of the interesting things that we have here, make sure I have the correct window open, is that if we are in the same, basically if we're in the same VPC network, we can talk to each other. And when I say we, I mean resources. Okay, so here this figure is a little bit, it's not tricky to parse through, but it's a little bit different than what we've been seeing. So here we have one big Google Cloud project, okay? So this is your default project or one that you've created for one of the labs. And we have 5 VPC networks, right? So we have US East and we have Asia East 1 are going to be the two regions that we are playing with here. In VPC network 1, we have two virtual machines. And then in 2, 3, 4, and 5, we have other resources, right? So 2 has VM3, VPC network 4 has VM4. If we are in the same VPC network, our resources can talk to each other with their internal private IP addresses. Okay, so if we have these two instances with the same internal IP, well, not the same, but they're in the same VPC network, they can talk to each other on these two addresses. Right, if I'm to, let me open this up and I can actually demonstrate this right now. I showed you this in another video, but it bears repeating. These two are able to connect. They're on the same network, right? Think of it like your local home network behind a router. You have a laptop, you have your phone, you have probably a smart TV, whatever you have set up. All these devices can talk to each other with their local device names, or with their local IP addresses. We'll probably resolve down to names too internally. But if I now create another VPC network, it's going to be a separate entity. It is basically its own walled garden that we can't talk to, which is exactly what you want. You want your resources to be protected. So if this is hopefully, okay, yeah, so this is up and running. So this is instance 1. I can say ping 10.186.0.2. And I should get a response. And, assuming the other machine is set up to handle ping, which Ubuntu is by default. So I'm getting a response on this internal number. Now, the one thing that I should mention too here, and I know I talked about this in one of the demo videos, but the notion of an internal and an external IP is important to note as well. So internal IP are those private internal addresses that the VPC network will use. Based on the number of VPC networks you have, there is a chance that you have some that are identical to each other. But they're going to be only resolvable inside of your network. The external IPs are unique. So I could say query this server from anywhere with its external IP, and I would get a response. Again, why would I get a response? Because it's open to the internet and that it can be pinged, right? So we would make that available. Now your question might be, how do I get them to talk to each other if they're in different VPC networks? Well, first of all, if you have different VPC networks, you probably have a separation of concerns, which is, a good thing. You want to try and partition out your resources as much as possible usually. But if I need them to talk, really the only way to do that is through the internet. So I'm going to call a publicly accessible IP address. So basically that external IP that I just showed you there. Again, this is a software-defined construct. They are separate entities. All right, so we have a little bit of information here. I'm going to kind of gloss over some of it. Your auto subnets mode in your VPC network is what you basically get by default. All right, so every time you create a new project, you get a new VPC network, you're going to get a subnet from each region, and you're going to get a set of predefined IP address ranges. You have a little bit less configurability, but you get kind of the base level of access, the base kind of configuration that you need. Right, you get default firewall rules, meaning that pretty much everything is blocked off unless you allow it. And it's good for, prototyping. It's good for getting things up and running, testing, whatever you need to do. Just like a little one-off thing. Don't necessarily make that a production goal, right? You want to understand your configuration, make sure it's configured appropriately. You can go the custom route too, where all of these subnets and ranges are defined by you, the administrator. There is no default firewall specified either, meaning that you have to go in, create the firewall, which generally is what you want because you know which ports should be open and which ports should be closed. Ideally, they should all be closed, and then you open up the ones that you need, right? And this is pretty much standard for any deployment, whether you're going cloud or not. You should be customizing your configuration for any kind of production system. Don't rely on the defaults because that's where the security holes tend to be in general, right? But again, you have the option between the two of these here. Okay,